Hello students, welcome back to physics sessions. Today we are going to discuss laws of motion, second part. In previous part we have discussed how to calculate the resultant force and acceleration of the system with the help of free body diagram. So there are different situations we have dealt with the help of the free body diagram to find the net force and the net acceleration of the systems. This is from the part 1. And today let us discuss laws of motion second part. Students, download our app Spark Academy. There are daily live classes, in session doubt clarifications, free material in our app, tips and tricks will be discussed with that concept. Previous year's questions will be included regarding the concept. Admissions are open right now. There is a classroom and online coaching available. So, short-term course available, crash course and regular batches are there. Students, in a week, our physics sessions will be on Tuesday and on Friday. We will be having the physics sessions on Tuesday and Friday. So if you are buying any course from the Spark Academy, you can contact any of these numbers which is given below for admissions. Sandhya, today I will be helping you the concepts from the laws of motion. That is part 2. So if you are buying any code, you can use the coupon SAM10. So by using this code, you can get the 10% discount on the course and you will be supporting me by using this code. So today in our session, we are going to discuss the friction, which is the important force in mechanics. So about the frictional force, so we are going to calculation of required force in different situations. So in different situations, how do we can calculate that required force, that is frictional force. So let us go to the session. So concept is friction. Friction, already we given the introduction about this in the part 1, which is the force. It is also a type of contact force when two bodies are in contact with each other. An opposing force which comes into existence when two surfaces are in contact with each other and try to move relative to one another. So if any two surfaces are in contact and there is a relative motion between that surfaces, to oppose that relative motion that contact surfaces, the force which develops in that situation is called friction. Next, types of friction. Mainly we need to discuss two types of friction. One is static friction. Static friction, you can observe this diagram. Students, in this chapter, to calculate the required force in different situations, Here also we need the free body diagram. Free body diagram means which indicates the forces acting. We just visualize the forces acting on that body in that particular situation. So let us see here, there is a book which is placed on the horizontal surface. We have drawn here all the forces acting on that book. Now object is the book here. There is an external force. To oppose this motion, frictional force, weight of the book will act downwards, which will be equal to mg, and a reaction force which is perpendicular to the surface of contact. In this situation it is acting upward. This reaction force is also called as normal reaction, which is equal to N. Next, when external force exceeds the certain maximum value of the static friction. So, in this situation, static friction develops means if we increase the applied force, which is the external force, this will also increase till it reach the limiting value or maximum value. So we can see here that maximum static friction is equal to mu s into n, since frictional force depends upon the normal reaction. This is also called as limiting value. Fs maximum is called as limiting value of the friction. So whenever external force is applied on object is being equal to friction, that is called static friction. So it is oppose the body, the tendency of the body to move from that place, means it will be at rest only. When the external force crosses this limiting value, we can observe the motion of the object. So we can F maximum or limiting value, we can represent like Fl or Fs maximum, which is equal to mu s into n. Next type of the friction is kinetic friction. When F external exceeds the certain maximum value, this one, see here, above we given maximum value of the static friction. If F external value is greater than that limiting value or maximum static friction value, then the book starts accelerating, and during the motion, kinetic friction force will present. You can observe in this diagram, in the free body diagram of the book, which is placed on the horizontal surface. In this direction, F external. So the book starts accelerating. This external force is greater than the maximum value. Then kinetic friction develops to oppose the acceleration of the object. So body just starts moving with this friction. So with this applied force, then kinetic friction opposes that motion. So the kinetic friction value is equal to mu k into 1, because frictional force always depends upon the normal reaction, where mu is called coefficient of friction. If it is mu s, we can say coefficient of static friction. If it is mu k, when body just starts moving, kinetic friction play in that situation. So it played that role when body just starts moving. That is called coefficient of static friction. And we can observe here coefficient of the kinetic friction, kinetic friction is less than the static friction, because which is easier, already rest, we are trying to make that object move. It is needed more force than the body already in the motion. So kinetic friction is always less than static friction. Coefficient of kinetic friction is also less than coefficient of static friction. Mu k less than mu s. So we can check when applied force act on object. With different situations you can describe the motion. Means first one, we are checking when there is an applied force and limiting friction value. If applied force is less than limiting friction, body does not move. Means body does not move and applied force should be equal to frictional force. Then only it has the tendency, it is about to move. It is at rest only. So less than means does not move. Applied force is equal to frictional force, that to limiting friction value. If applied force is equal to limiting friction value, body is on the verge of the movement, means it is about to move. If the body is initially rest, it moves with the constant velocity. So on this condition, it is about to move. If it is initially rest, it moves with a constant velocity. If applied force is greater than the limiting friction value, or external force is greater than the limiting friction, that is the maximum friction, then body starts accelerate, means body moves with an acceleration. Then we can find the acceleration of the object with this formula. That is means net force. You can observe this second diagram, what we have drawn this in this way, if externally. In this direction frictional force will act if it is the limiting. So F external greater than FL means here we can consider kinetic friction. So whatever friction develops here, that value we need to take here. And this way normal reaction force, weight will act downwards. So net force acting on the object, so it has the tendency to move along the direction of the force. So we can write net force means F external minus frictional force, which is equal to mass of that object into acceleration. So from this we can find the acceleration, that is the third case. So we can check when there is an applied force and limiting friction value, whether the object is moving or not moving. So if it is accelerating, we can find the acceleration. Next concept is angle of the friction. Angle of the friction, you can observe the free body diagram of an object which is placed on the horizontal surface. You see, this is the force, applied force. P, like a pulling force. You can imagine like a pulling force. So P is the applied force and it is frictional force to oppose the motion. Friction develops. Just representations are different. The meaning, in this way applied force, in this direction frictional force. R is the normal reaction force, RRN. Weight of the object will act downwards. Angle of friction means angle made by the resultant, S is the resultant, with the normal reaction. So to find that angle of friction, tan theta from here, tan theta will be equal to, this friction is the limiting friction, means which is the maximum friction develops opposite to applied force. So we can take from here, you can just draw an imaginary parallelogram in this. If it is FL, this side is also FL. Then tan theta will be equal to FL by R, opposite by edge side. Now, therefore, tan theta is equal to mu s when there is a limiting friction value, which is the maximum static friction. So here the coefficient of that friction is being equal to tangent of the angle made by the result. And what is the angle of friction means? Theta is equal to tan inverse of mu L or mu S. See, static friction has maximum value which is also called as limiting value. So we represent mu S or mu L, both are same. So this is the angle of the friction, angle made by the resultant with the normal reaction force. And let us find the resultant of the normal reaction and friction, which is equal to under root of limiting friction whole square plus normal reaction whole square, by applying the Pythagoras law in this diagram from here. So that resultant, as we know, FL is equal to limiting friction value will be equal to, it is mu into N or mu into R, which will be equal to mu into mg, and R is equal to R is balanced by mg. So R value is mg, so we substitute here, then the resultant is being equal to mg into under root of mu square plus 1. Next, angle of repose. Angle of repose means angle made by the inclined with the horizontal when object is placed on the inclined surface. So now alpha is angle of repose. Means at which angle the body just starts sliding on the surface. That is called angle of repose. Here we have drawn the free body diagram. We are given with the free body diagram. What are the forces acting on this object? See, weight will act downwards perpendicular to the surface of earth. Reaction force perpendicular to the surface of contact. This is reaction force. And weight resolve into its components, mg cos alpha, mg sin alpha. So it has the tendency, when it is on the inclined surface, with mg sin alpha, it can start move on the surface, inclined surface. To oppose this motion, opposite to that force component, limiting friction develops. So in this situation, for condition of equilibrium, EQ whole power n means equilibrium, means all forces will balance each other. Sum of the forces will be equal to 0. That is the equilibrium condition. Means vertically, horizontally, the magnitude of forces are equal. So see here we equated limiting friction value is balanced by mg sin alpha and reaction force is balanced by mg cos alpha. So if these are equal, object is at the equilibrium condition. Now we can find the angle of repose, which is the angle made by the incline with the horizontal. That body just starts move down on the surface. So you just take limiting friction value FL by R is equal to tan alpha. mg sin alpha by mg cos alpha gives tan alpha. So here we can write F by R is nothing but mu s, because we know that limiting friction is equal to mu into R. So FL by R will be equal to mu. So mu is equal to tan alpha as well as tan theta. You can see here we have proved at the angle of friction. So angle coefficient of static friction is equal to tangent of angle of repose as well as tangent of angle of friction. For mathematical expression, accidentally their formulas are being equal, which is mu is equal to tan theta or mu is equal to tan alpha. But theta is when object is on the horizontal surface, alpha is the angle of repose when object placed on the inclined surface. Here I given coefficient of friction between a body and a wedge. So to understand this, let us go to first find the acceleration when objects are on inclined surfaces. Again I come to this slide. So let us check the next concept. So now we are going to calculate the required force in different situations. Here we are given with the situations. First situation is minimum pulling force P to move the body up on an inclined plane. So the body moves up, the pulling force will act this direction. It is pulling that way to make the body move up on the inclined surface. It is making angle theta alpha with the inclined surface. Now this pulling force resolve into its components. You can observe in this free body diagram. Angle of inclination is lambda and pulling force makes angle alpha with the inclined surface direction. Now this pulling force adjacent side is P cos alpha, in this direction P sin alpha. So perpendicular to inclined surface there are two forces, R plus P sin alpha, and next weight of this block resolve into its components. Here angle of inclination is lambda, so here angle also will be lambda. So because weight with the vertical is making same angle, that is angle of inclination lambda. Now it resolve into W cos lambda, opposite to this will be W sin lambda. As it is moving upon the inclined plane, so direction of motion is this way. Frictional, limiting friction develops opposite to that. So to oppose the relative motion between the object and the inclined surfaces, limiting friction develops along this component. So you can see along W sin lambda, limiting friction develops. So you can write here for equilibrium condition, equilibrium condition means all the forces, sum of the forces acting on object will be 0. When sum of the forces will be 0 in all directions if they balance each other. So we just equate vertical and horizontal. So vertically we can write C, R plus P sin alpha will be equal to W cos lambda. Vertically, that I can write it as R is equal to W cos lambda minus P sin alpha. Next, horizontally means along the inclined surface, P cos alpha is balanced with these sum of forces. So we can write P cos alpha is equal to limiting friction value plus W sin lambda. So this we can write limiting friction value is equal to P cos alpha minus W sin lambda. And we know that since limiting friction value is equal to Fl means limiting friction here or maximum static friction develops in that situation is always equal to mu into R. So we substitute, R value is this one. So substitute Fl in above equation. So Fl is being equal to mu R means mu into R value. So by substituting Fl in the, take it as equation 2, this is 1. In equation 2, we can list out the required pulling force to make the object upon the inclined plane. So here it is moving upon the inclined plane. Now this is the result. So you just balance the forces vertically and horizontally, and simplifying this, you will get the minimum required force to move the body upon the inclined plane. So we will get it as W into sine of theta plus lambda by cos of alpha minus theta. Where theta comes, you can get a doubt. There is only alpha and lambda. What about theta? Yes, see here. in previous slide we have already proved coefficient of friction is equal to tan theta. Means mu is equal to sin theta by tan theta. So by substituting mu value, f value as this, in f, r value is like this, cos lambda minus p sin alpha. Substituting all in equation 2, we get that minimum pulling force. Next situation, minimum force to move a body in downward direction along the surface of inclined plane. First situation is to make the body upon an inclined plane. This situation is a downward direction along the surface of inclined plane. So here also free body diagram plays such an important role in the laws of motion chapter to find the required force in different situations. So here also we have already given with the visualized direction of forces on that object. In this F means limiting friction is acting this way because object is moving downward. So to oppose that relative motion between the contact surfaces, this direction friction will act. So weight will act downwards, it will resolve into its components. Now pulling force is acting in this direction, is making alpha with the direction of inclined surface. So now this pulling force or external force resolve into its components along W sin lambda P cos alpha, because that is adjacent side. Opposite side is normal reaction direction, that is P sin alpha. So now for equilibrium condition, just we have given all the forces acting on that object when it is on the inclined surface. That for equilibrium condition of the object means you just balance the forces vertically and horizontally. So vertically I am writing R equal to, actually it is R plus P sin alpha is equal to W cos lambda, can be written as W cos lambda minus P sin alpha. Horizontally FL is being equal to, limiting friction is being, it is balanced with W sin lambda plus P cos alpha. And we know that limiting friction value is equal to mu into R. R means this value we have to substitute here, and mu is equal to tan theta. We have proved at angle of repose that coefficient of friction is being equal to tangent of the angle of repose. We are taking like, and from this we can write sin theta by tan theta is nothing but sin theta by cos theta. And substituting mu value, R value here, and we can find the minimum force to move a body downward direction. So now it is the force, that is P is equal to W sin of theta minus lambda by cos of alpha minus theta. So this theta is angle of repose, at which angle it can start move. So that is theta. Alpha is angle made by the pulling force with the inclined surface. Lambda is angle of inclination. Our next concept, acceleration of a block against friction. The first situation, acceleration of a block on horizontal surface. Object is on horizontal surface. This is the applied force. P is nothing but F external or applied, and in this direction frictional force will act. If it is moving, if it is accelerating, so they given like this, along the direction of applied force or external force, it is accelerating, so that is NA. Weight of the object will act downwards. Reaction force is perpendicular to the surface of contact. So this is the formula of net force acting on the object. Net force acting on object means we take in the direction of motion the resultant force. Direction of motion is this direction. So in that direction F external, opposite to the direction frictional force. So P minus Fk is being equal to net force. Net force is nothing but mass into acceleration of the object. So in previous session we have discussed already with the free body diagram how to take the net force or resultant force acts on the object. In this situation it is Ma is equal to P minus Fq. So acceleration of that block you can find A is equal to P minus Fq by M. So this is the situation when object is on horizontal surface, when friction comes to play in that situation. Next, acceleration of a block sliding down over a rough inclined surface. Rough inclined surface means friction will come to play its role. See here, it is sliding down. Here we are given with the component of forces acting on the object. So mg sin theta component helps the body to move down on the surface. So it has the acceleration downward. To oppose this relative motion between contact surfaces in this direction, frictional force will act. That too, limiting frictional or maximum friction develops. FL or F. We are talking about friction here. This is friction, not applied force. Angle of inclination is theta. So now for equilibrium condition, we just write vertically and horizontally balanced forces. Or you can apply resultant force acts on that object. So here net force or resultant force will be equal to, along the direction of motion, sum of the forces we need to consider. Because vertically here R is equal to, R is balanced with weight of the object, reaction force. So that along the direction of force, resultant force is being equal to mg sin theta minus FL. So the next step, resultant force means mass into acceleration or net force, is equal to mg sin theta minus FL is always equal to mu into R. So from here R is mg, sorry, R should be mg cos theta because it is adjacent to angle, it should be mg cos theta. So now R is balanced with mg cos theta, substituted here R value instead of R mg cos theta. So from all sides m take common, gets cancelled. So now the acceleration of an object on a rough incline while sliding down is g into sin theta minus mu cos theta. And let us see retardation of a block sliding up over a rough inclined plane. So here retardation means negative acceleration because when it reaches the top of the inclined plane, here velocity becomes 0. So slowly velocity decreases, so that acceleration is called retardation. Here also given with the free body diagram. So it is now sliding up, direction of motion is this direction. To oppose this motion, in this direction, maximum friction or limiting friction will act. In that direction, there is m sin theta component also. So total force down the plane is mg sin theta plus f, and it is reaction force is perpendicular to surface of contact, and this will be mg cos theta. So in this situation, net force or resultant force along the direction of motion is equal to, this side there is no force because direction of motion is this way, friction also acting opposite to that. So we have mg sin theta plus fl, that is fl. So resultant force means ma, mg sin theta. fl means, fl value we need to substitute like mu into r. In this situation, r is balanced with mg cos theta. So next step, r value substituted as mg cos theta. So ma is equal to mg sin theta plus mu into mg cos theta. So from both sides, here RHS side taking common m and LHS side m gets cancelled. So retardation, when the block sliding up over a rough inclined plane, retardation is A is equal to G into sin theta plus mu cos theta. Here let me analyze the situation if there is no friction. If surface is smooth, if the surface is smooth, we can tell frictional force acts on the object is G. Means it has the tendency to move as the surface is smooth, no need of friction here. So now what is the acceleration of the block while moving down? No friction means, so here mu value 0. So in this equation, put mu value 0, A is equal to G sin theta. Acceleration moving up, when it is moving up, so direction of motion is this way. Even here also we need to put mu value 0. We get 8 G sin theta, but opposite direction, so you can simply say minus G sin theta. The sign is indicating against the direction of motion. So this is the case when the surface is smooth, inclined, that to inclined surface. So now we got acceleration in different situations, on horizontal, on rough incline, on smooth incline surface. So now let us go to the previous slide. Yeah, here the coefficient of friction. Here the situation is coefficient of friction between a body and wedge. You can observe we are given with the smooth and a rough wedge. So smooth means friction 0, and if the distance travelled and it is moving down, object is initially at the top of the wedge. Now the distance travelled by that object on smooth and rough is the same. Here we have to remember one point. The time taken to travel down the rough incline is n times greater than smooth incline. Smooth incline surface, that is nt we need to take. On rough surface, what is the time taken means? N times greater means n into t. Now let us see. For smooth wedge, the distance travelled by the object. So initial velocity 0 here. Smooth initial velocity 0. It moves like a free fall object. So put u0 here, half at square. It is on inclined surface. So the acceleration while moving down, we take a is equal to g sin theta. Just before we have put. So the distance travelled by the object on the smooth wedge is equal to half g sin theta t square. Next, for rough wedge, friction will come to play here. On the rough incline moving down, we have proved that is g acceleration is g into sin theta minus mu cos theta. So here u0, so ut plus half at square, we get distance travelled on rough wedge is half at square, where a is equal to g into sin theta minus mu cos theta. So from 1 and 2 equations, so see here, this is equation 1 and this is equation 2, and you need to observe here in equation 2, time taken on rough wedge is n times greater than time taken on smooth incline. So we consider t as nt. So nt whole square. So from equations 1 and 2, so whereas the distances travelled equal, so distance travelled in first case is equal to distance travelled in second case. We can find the coefficient of friction, which is equal to tan theta into 1 minus 1 by n square. So when we are given with rough and smooth inclined surfaces simultaneously, the distance travelled is equal. To find the coefficient of friction, we can use this result. Next situation. Next concept, work done against the friction. So first situation, to find the work done against friction, work done over a rough inclined surface. Already what is acceleration and what is the distance travelled we have seen in previous slides. When object is on a rough inclined surface. To find the work done, that too against friction, work done formula is force into displacement. Force formula is m into a into s. And now you can observe this free body diagram. Direction, it is accelerating up on rough incline. So in previous slides we have seen acceleration on a rough inclined plane when it is moving up the surface, up the inclined surface. That is g into sin theta plus mu cos theta. Now the force will be equal to m into this acceleration into s. So it becomes mgs into sin theta plus mu cos theta. Just from the previous slides, just take acceleration when friction plays. We are finding work done against the friction. So you need to consider that frictional value with acceleration due to friction. So this will be the acceleration and this is the work done. Next case, work done over a horizontal surface. So work done is force into displacement. See here, object is on the horizontal surface. In this direction, pulling force along the horizontal direction, which is nothing but external force. To oppose this motion, opposite to external force, limiting friction will act or maximum friction will act. So now we can take, we know that the limiting friction is always equal to mu into r. In this situation, r is balanced with the weight of the object. So finally FL is being equal to mu into M into G. So work done will be equal to F into S. Here F is frictional, that too limiting friction. Now we can write mu into mg into S. This is work done against the friction or a horizontal surface. So if we observe here, it is depending upon weight of the body mg, material and nature of the surface in contact means mu, because mu always depends upon nature of the material of surfaces in contact, and S is the distance, so it is dependent upon distance more. So work done against friction, or when there is a rough surface, friction will act. So work done against friction, the possible cases, or a rough incline or a rough horizontal surface. Or a rough horizontal surface mu mg into S, or a rough incline mg S into sin theta plus mu cos theta, because this is the acceleration when the friction acts. Next situation, motion of two bodies, one resting on the other. This is one of the important situations about the frictional force. For numerical solving, very important. So let us see, when objects are one over the other, we are given with the situation a force F is applied to the upper body. Then following four situations are possible. So here we are given with the diagram. See, there are two blocks A and B. Block B length is L. Block A is placed over the block B, and applied force is on the upper body, that is on block A. So this is external force or applied force. This is applied force. So if there is no friction means here frictional force 0, and here, because when the surfaces are in contact, to oppose the relative motion between them, frictional force will act. So in this situation, no friction. So no friction means only block A will move with the applied force. Block B will be at rest. So acceleration of block A is F by m, applied force by its mass. Acceleration of block B is 0 because it will be at rest only. No force acting on that one. And here we are given with the time taken. A will fall from B after some time, after it travelled this distance with this applied force. It can fall off from the surface. It will fall, A will fall from B after time. What is that time? So we can find. So initially at rest, so we have found the distance travelled by it, which is the L, half AT square, and the acceleration of that block is A by M. So from this we can write T is equal to under root of 2L by A, where A is equal to F by L. L is nothing but distance travelled. So from this time taken for block A to fall off from the block B, because there is an applied force. So if no friction, this way we can find acceleration of the blocks and time taken of block A to fall from the surface. Next situation is if a friction is present between A and B only, and applied force is less than limiting friction. We know that if applied force is less than limiting friction, that object will be at rest only. It will not move. The body will not move. And here, but whereas friction present between the blocks A and B. So here friction not equal to 0. With this applied force in this direction, limiting friction will act on A. On block B also, frictional limiting friction will act to oppose the relative motion between. So when there is a friction between A and B and limiting friction value is there, applied force is less than that. So the individual blocks motion we cannot see. We can see the combined system will move together due to that applied force. Means both can have the common acceleration. Acceleration of V is equal to acceleration of B, which is equal to F by m plus n. Means total means block B mass is capital M, block A mass is small m. So when friction present between the blocks and no friction at the contact of horizontal surface and block B, only between the blocks friction present, due to that the system will move with a common acceleration. And third situation, friction is present between A and B only and applied force is greater than the limiting friction. So we know that applied force greater than limiting friction, the body starts accelerating. But here the two blocks are one over the other, applied force is only on one object. So we can see the individual accelerations because F is greater than Fi. You can see the free body diagram of A. So in this situation, this is the applied force. In this direction, applied force is there. So the friction, kinetic friction develops to oppose the motion of A while cause the motion of B. That causes the motion of B. So resultant force on block A from this free body diagram, resultant force on block A is applied force minus kinetic friction is equal to net force, that is mass into acceleration of that block A. So from this we can find A which is the acceleration of block A, F minus Fk by m. And Fk is equal to mu k, mu is equal to mu r, Fk is equal to mu r because normal reaction force will act this way. That reaction force balanced with the weight of that. So Fk will be equal to mu mg. That we have substituted here. If there is Fk, there is mu k. So acceleration of block A. This is the condition when applied force is greater than limiting friction, we can observe the individual accelerations of the block. So here kinetic friction opposes the motion of A over the B while will cause the motion of B. So let us see free body diagram. That friction will cause the motion of B. So that frictional force, kinetic friction is equal to mass of the block into its acceleration. So acceleration of block B will be equal to kinetic friction by its mass. And again we know that kinetic friction is equal to mu into mg. Yes. So this is the situation when applied force is on the upper body. These three cases. Next, force applied on the lower body, then the following situations are possible. You can see here when there is no friction. So immediately no friction means on which block force is there, that body will accelerate. So acceleration of B is equal to applied force by its mass. And there is no applied force on A, so it will be at rest. And block B Means here also when block A will have the tendency to fall back when it is moving forward. So T is equal to the time taken to fall from the after travel this distance under root of 2L by A. So we can write here acceleration of the block is F by M. We substitute F by M here. Now second case, if a friction is present between A and B only and applied force is less than limiting friction. In this situation, block A motion can be described with respect to B, means non-inertial frame of reference, because now B is the reference frame for the block A that is accelerating, which is F by M. So object motion with respect to accelerated frame is non-inertial frame. So in case of non-inertial frames, pseudo force will act on body A, that is F dash. So pseudo force means which is equal in magnitude of applied force and act in opposite direction. So here also it is like MA only. So pseudo force is equal to MA, where A is because bodies will move together at this condition. Acceleration of A and acceleration of B can have the same, that is applied force by total mass. And about block A motion, pseudo force will act, so we can write M into F by N plus A. And what is the limiting friction develops, that is mu into mg, whereas with pseudo force less than Fl, so this value m into F by n plus m will be less than mu is mg, so it will not move. Bodies will move together. So what is that condition, applied force? If they ask what is the friction develops here, like limiting friction. Limiting friction value is this much friction develops. Because on this direction frictional force will act. So not here, not at this contact, between A and B only. So on A, limiting friction will act. On B, in this direction it will act. Now third case, if friction is present between A and B only and F is greater than limiting friction. F is applied force, Fl is limiting friction. Now body accelerates, where it is greater than Fl. Indubitable accelerations will be there. So free body diagram of A. So here whatever kinetic friction develops, it opposes the motion of B while will cause the motion of A. So only force acts on A is frictional force, that is kinetic friction. So if net force is equal to frictional force. Net force means resultant force, limiting friction, or yes, it is accelerating kinetic friction. So m into acceleration of block A is equal to kinetic friction value is mu k into g. So acceleration of block A will be equal to mu k into g. And the free body diagram of block B, you can see here, it is applied force opposite to the kinetic friction. Then the net force is this much. F minus Fk is equal to MAB. AB is F minus Fk value is mu k into mg by m. And in this case, actually, what is the limiting friction develops between them, whereas applied forces on the lower block, it will be equal to, means F is equal to like mu into reaction. So here reaction force will be like m plus m into g. It is balanced with m plus m into g. So limiting friction value is mu into m plus m into g. This is the case applied force is on the lower body. 3 cases possible: when no friction, when friction between A and B, and F less than FL. Friction between A and B only, F greater than FL. Students, download the app for great discounts on our courses. So you will be having the free handwritten notes in the app, study materials, previous year's questions and mock tests. So you can buy any course. If you are buying the course from the Spark Academy, you can contact for admission and for admissions any of these numbers which is displayed here. So here the timings are mentioned. Students, don't forget to enter a coupon code SAN10 if you are buying any course from the Spark Academy. By using this code, you will get the discount on that course. So there are daily and on-demand live sessions. Yeah. So let us see one more concept which is important about the frictional force. Stopping block due to friction. So along with the block over the block, this is also important about the frictional force. See here, on horizontal road, now the block is moving with initial velocity u, travel this much distance and comes to rest. On horizontal road, here retarding force will act due to friction, because it opposes that motion. That is what it is coming to rest. So F is equal to ma. Net force is of this block, take mass n. So net force is ma, that is being equal to friction. So to oppose this motion in this direction, limiting friction will act. That is equal to mu. So from here we can write, actually this is Fm, which can be written as mu. So ma is equal to mu into mg, because in this free body diagram, reaction force perpendicular to surface and it is balanced by the weight. So that the deceleration due to the retarding force, which is the friction, the deceleration of the object can be calculated mu into g. And what is the distance travelled before coming to rest? Now we are using kinematic equation v square minus u, v square equal to u square minus 2as. Final velocity 0, a is mu g, then s will be equal to u square by 2 mu g, or you can write s is equal to u square by 2a also, where a is equal to mu g. And we can write the formula in terms of momentum, which is equal to p square by 2 mu m square g. And next, time taken to come to rest. What is the time taken? So we are using v equal to u minus at form. Final velocity 0, initial velocity u, acceleration or deceleration for this when it coming to rest is mu g. So time taken will be u by mu g. If object is on inclined road, it is moving with initial velocity, it is moving up the inclined surface and its final velocity becomes 0. This much distance travelled on the inclined surface. Using kinematic equation v square equal to u square minus 2as. So the distance travelled by the object up the inclined surface before coming to rest is equal to, just substitute a value as up the inclined surface, acceleration is a into g sin theta plus mu cos theta. So we substituted that, and s is equal to, it is calculated as u square by 2g into sin theta plus mu cos theta. So students, these are the different situations to calculate the required force, that is due to friction. So let us see the previous year's questions. A car of mass 1.2 tons is traveling along a straight horizontal road at a speed of 20 meters per second. When it brakes sharply, then skids. Friction brings the car to rest. So it is coming to rest. If the coefficient of friction between the tires on the road is 0.8, calculate the deceleration, distance travelled by the car before it comes to rest. So this question is related to this concept. So see here, deceleration means A equal to mu g. Stopping distance means the distance travelled is u square by 2 mu g. So we can use this formula. So first find the deceleration, that is A is equal to mu g. Mu is given as 0.8. So 0.8 into g value is 9.8. So next we need to find the distance travelled. Distance travelled is equal to u square by 2 mu g. So it is equal to u is 1. U is 20. So 20 into 20 by 2 into 0.8 into 9.8. So here acceleration will be equal to 9.8 into 0.8. So it is being equal to 7.84. So it is 400 by 7.84. So we can write it as 400 divided by 7.84 is equal to 51.02 meters. It travels that much distance. So next question. We are given with 400 gram package lying on a horizontal surface is attached to a horizontal string which passes over a smooth plate. When a mass of 200 gram is attached to the other end of the string, the package is on the point of the node. Find mu. We need to find coefficient of the friction. So just draw the free body diagram of this. So here 200 grams means 2 into 10 power minus 3 kg into g value. And next 400 grams, it is reaction force will act upward perpendicular to surface of contact. 400 grams means 4 into 400, sorry, it is 200 into 10 power minus 3. Here 400 into 10 power minus 3 into g. It is the weight. And there is a frictional force. So this weight creates the tension along the string. So that tension will act this way. And here limiting friction will act. So we can see here for the condition of the equilibrium, limiting friction is equal to T. But T is equal to 200 into 10 power minus 3 into G. Means 0.2 into G. And the limiting friction FL will be equal to mu into R. R means like mg. So reaction force is balanced with this weight, that is 400 into 10 power minus 3 into g, which is equal to mu into 0.4 into g. So substituting this equation, mu into 0.4 into g is equal to 0.2 into g, where g is acceleration due to gravity. So without substitution we can cancel here. Then mu is equal to 0.2 by 0.4, which is equal to 1 by 2. So students, here we are given with the other question. A 5 kg box on a horizontal table is pushed by a horizontal force of 15 newtons as shown in the right. If the coefficient of friction is 0.4, will the box move? So applied force is in this direction. Frictional force develops opposite to that to oppose that relative motion. Limiting friction develops this way. So if the block is moving, if it moves or accelerates, then limiting friction, 15 newtons, that is the applied force, must be greater than limiting friction. So just we find that limiting friction here. Fl is equal to mu into R. Here R is the reaction force. It is balanced by 5 into G. 5 kg into weight is in the form of mg. So mass is 5 into G. So we can write here mu is 0.4, mass is 5, G is, let us take approximate value 10. So it is being, Fl is greater than 15 newtons. That is 15 newtons less than Fl. So will the box move? If it moves, this is the condition. But 15 newtons less than Fl. So it will not move. So students, with the help of these techniques, you can try the questions about the frictional force in different situations. Thank you.